Okay, students, so welcome to Chapter 4, Part 3. So Part 3 is really going to address this whole idea of properties of distribution, of being able to look at a distribution and really figure out what's going on with our sample in terms of the distribution of cases and distribution of scores and responses. And so we've learned in Chapter 2, when we talk about measures of central tendency, this whole idea of the mode. Well, when we talk about modality, it's somewhat similar, but instead of just looking at one particular response, we're actually going to be looking at the entire distribution of all of our responses to see, do we see one major hump, two major humps, not necessarily one particular response. So this is the idea of modality. And we see that we can use modality almost for all levels of measurement. We can look at nominal, grouped ordinal, ungrouped interval ratio, and also grouped interval ratio as well. But let's talk about some new concepts that you're going to learn about are these ideas of skewness and kurtosis. So we don't use skewness and kurtosis when we have nominal variables and if we have grouped interval ratio variables. We use skewness and kurtosis if we have ungrouped interval ratio variables, right? Numerical values, age, temperature, time, weight. But also, if we can make sense of a mean when we have grouped ordinal variables. And recall, we can calculate and report a mean for grouped ordinal variables if that particular variable has 5 or more groups or responses, and we can make sense of the interpretation of that particular variable and the mean. If you can calculate a mean for a grouped ordinal variable, then you can also calculate the skewness and kurtosis. But remember, modality, skewness, and kurtosis are really just properties helping us understand the patterns that we can see in the data for a given variable. Your textbook actually goes into much more detail in terms of calculations of skewness and kurtosis. For the purposes of my class, you don't actually have to learn how to calculate skewness and kurtosis. We're going to use SPSS to give us the statistics, and we can interpret them. And we'll also learn a different way that we'll see how we can figure out skewness and kurtosis without actually having the numbers, but really looking at the shape. So let's move on and talk about these in more detail. So let's talk about modality. It's a number of peaks in your distribution. So one thing about modality is that really we can either have a unimodal, right? If there was just one group or one score that was most frequent. We can either have no mode if all the scores and all the groups were equal in size, same frequency. Or we can have bimodal or multimodal, where multiple groups are more frequent than all the others, and those groups have the same frequency. But in the terms and in the sense of modality, you want to think about modality as being multiple modes, but really more peaks, not necessarily individual groups or individual scores. So looking at this distribution curve here, which column would you say was the mode? The second column, right? We see it's the tallest and highest peak. But looking at the entire distribution itself, all the way to the left of this first column, all the way to the right, very, very small column at $250,000. How many peaks do you see overall here? One peak, right? One major peak. So in this sense, it's unimodal. The peak is on the left. And yes, there's only one mode. But look here. We would say that this point here, whatever this data point right here, this is the mode, right? It's the tallest peak. But look at the entire distribution. Look at the entire curve itself. How many peaks do we see? There are 2 peaks, right? So even though this one spot here is the mode, we have pretty much 2 major peaks. So we would consider this a bimodal distribution, right? There may be one mode as a measure of central tendency, But in terms of the distribution itself, it's bimodal. Here are a couple other ones. Looking at nominal variables. Ethnicity. What's our mode? Puerto Rican. But looking at the entire distribution, how many peaks are there? Only one, right? So again, in this case, there's only one mode, and the distribution itself is unimodal. But look here, subsidiaries. We have our 7 different vendors. What's our mode? Which vendor is our mode? Vendor C, right? But in terms of the entire distribution of these 7 vendors, we have 3 modes, right? We have multimodal. So this may be useful in saying, okay, well, in one fair, our very first fair, we see that we had 7 vendors come out, and really 3 of them really kicked butt, and they sold a lot. So next year, maybe let's cut down on the costs by not necessarily having 7 different vendors there. Well, let's bring in these 3 that are going to bring in the most money and get the bang for the buck. So even though we have a specific mode as a measure of central tendency, overall, we have 3 modes, vendors C, E, and G. Okay, let's move on to our second point of distribution, skewness. And you may have heard me talk about skewness, dropping this word here and there when we're talking about the mean and the median, especially when we're talking about Wilt-Chamberlain. So really skewness is how far off center are you from the midpoint, right? What do we know the midpoint to be? By definition, the median. So skewness is essentially saying how far off from the median, from the midpoint, are you? And we can apply skewness to, again, grouped ordinal variables if we have 5 or more groups and it makes sense to interpret a mean, and if you have ungrouped interval ratio variables. So just think about this way. You have political affiliation, right? You have left-wing liberals, and you have all the right-wing conservatives. And pretty much everybody kind of falls in between here in some spectrum, right? It's really just how far off are you from being complete moderate to being a total liberal or a total conservative. So we can think about positive skewness or negative skewness, or skewed to the right or skewed to the left. So this is the terminology that we would use when we're talking about skewness. Positive or negative, or left or right. So let's look here. On this left chart, this left distribution, we have what's called a nice normal distribution, right? A nice bell-shaped curve. And when we have a nice normal distribution like this, there is no skewness at all. But notice here, we have our little hump, or rather our big hump, to the left. And we have our tail to the right. So when we see distributions this way, where the hump is to the left and the tail is to the right, do you think this is positive skew or negative skew? What do you think? Well, this is positively skewed. It's skewed to the right, which then means this other graph here means that this is skewed to the left, a negative skew. So the idea when we're thinking about skewness, we're always referencing the tail when we want to say whether it's positive or negative, or if it's left or if it's right. Notice, for the positive skewness, the tail itself is to the right. And when we're talking about negative skewness, the tail is all the way to the left. So thinking about Wilt-Chamberlain, we knew Wilt-Chamberlain was a huge, high outlier, right? 20,000 sexual partners. Well, if we're looking here, which of the 3 graphs would describe Wilt-Chamberlain and lifetime sexual partners? Is it going to be the first one, the middle one, or the third one? It's going to be the middle one, right? If we look all the way to the right, this is where Wilt-Chamberlain is going to be. Remember when we calculated the mean versus the median? It was like 1,825 was the mean when we calculated Wilt-Chamberlain in there. But when we calculated the median with Wilt-Chamberlain in there, it was something along the lines of 5 or 7.5 or something like that. And so what's happening is that your outliers, your extreme scores, wherever they may fall, either all the way high
and to the right, or really low and small outliers to the left, they're going to pull your central tendency. They're going to pull the middle towards our direction. So Wilt Chamberlain is pulling this whole distribution to the right, which is why the hump is all the way to the left, because this is where most people are lying as far as their answers in the distribution. But then you have this one outlier who's then pulling that nice hump to the right. So when we're thinking about skewness and central tendency, again, in the normal distribution, the mean equals the median equals the mode. This is a very important and very useful property, that the mean equals the median equals the mode in the normal distribution. There's no skewness. However, in a right-skewed positive distribution, the mean is bigger than the median and the mode. Conversely, on the left or negative skewed distribution, the mean is smaller than the median and the mode. So let's take a look. What do I mean by that? So here again is a normal distribution. The mean, signified by mu, the median, and the mode all line up. But here, this is the example for Wilt Chamberlain, right? Wilt Chamberlain is going to be all the way to the right over here. But look at the very top of the peak of the hump is going to be your mode. Your median is going to be the middle distribution, the 50th percentile. And then we see the mean. It's going to be all the way to the right, right? Because remember, the mean is going to be sensitive to our outliers, so it's going to be pulled to the right. Conversely, with negative skew, if you have a super, super low score, that mean is going to be pulled to the left, and it's going to displace the median and the mode, so now all three of these are not lined up. Make sure you understand this concept here.
Okay, so let's take a look at a couple of diagrams that you've seen before already, but now let's look at them in the context of trying to determine skewness. So go ahead and pause the video and see if you can figure out the skewness of income distribution and the skewness of the box and whisker plot that we created in part 2. When you think you have your answer, go ahead and continue playing this video. Alright, so let's see if you got skewness correct. So looking at income distribution. So we can look at it two different ways. First, let's look at the actual shape itself without looking at any numbers. So do we want to look at the hump or the tail to figure out if it's positive or negatively skewed? We want to look at the tail. So we see the tail is in, what? Is it on the positive side or the negative side? Well, there is no negative here, but on the bigger side, the positive side, or is it towards the zero side? We see it's on the positive side, so it's positively skewed. So that's just looking at the shape of it. But notice there's actually numbers here. And if we look down here below, we actually see they've given us the median as well as the mean, and then we can actually determine or kind of guesstimate, and I really don't like using that word, but estimating what the mode is. So previously we learned that if we can't really tell based on looking at the shape of it, let's compare the mean to the median to the mode in this distribution to tell us if that's going to give us any more idea. Well, thinking back about Wilt Chamberlain, what happens when Wilt Chamberlain is part of our sample? Does he pull the mean in one direction, or does he pull the median in a different direction? He pulls the mean, right? The mean is sensitive. So looking here, we see the mean is greater than the median, which means the mean is being pulled up higher because we're going to have bigger outliers on the positive end. So that's going to pull the mean up, whereas we see the median is at 46,000, the average is at 63,000, and we see that the mode is almost at zero. So let's say about, what's that, maybe 15,000? So we can see the three relative to each other, And since the mean is to the right of the median, it's greater than the median, it's also then indicating that we have positive skewness. So let's take a look at our box and whisker plot. Well, we don't really have numbers. Well, we actually have numbers. We can see down at the bottom. But we can, again, looking at the mean relative to the median, we see that the mean is to the right of the median, so this is positively skewed.
Okay, our last distribution property, kurtosis. So as much as skewness talked about mean, median, and mode, and really where is the mean relative to the midpoint, really all about measures of central tendency, kurtosis is talking about dispersion. How much do the actual scores decline from our mean? Do they decline much faster and it's a very steep and narrow peak? Or do they decline not so fast and tend to be more flat, like the pita bread here? And just like skewness, we can use kurtosis for grouped ordinal variables that have 5 or more groups, and it makes sense to interpret and calculate a mean. And when we have ungrouped interval ratio variables. For kurtosis, make sure you know positive and negative kurtosis, but you don't really have to know these crazy, funky-looking words, leptokurtic or platykurtic or mesokurtic, which we'll see in the next slide. So think about kurtosis as how peaked or how flat is your distribution. Okay, so here we have a visual of kurtosis. So this first one here, graph A, first one here, distribution A, it's just a nice normal distribution, bell-shaped curve. So this is our mesokurtic, it has no kurtosis at all. Distribution B, though, is a peaked, much narrower curve. And distribution C is a flatter, wider curve. So between B and C, which one do you think is the positive, and which one do you think is the negative kurtosis? Well, B is going to be the positive one. This is more peaked than normal. And C is going to be your negative kurtosis. So the idea that we see here is that for positive kurtosis, most people are hovering right around the mean. There are no outliers. And most people are going to be right around and clustering that average. Compared to negative kurtosis, you see we have a wide distribution of cases. So you're going to have a much wider range, much bigger standard deviation. But look at your mode. Your mode is not going to be very much. You're going to have more people that are going to be spread out than you see more people within a smaller range of scores. So looking at kurtosis, we can talk about range, right? We can figure out standard deviation in a sense, but really being able to see the distribution among your cases.
Alright, so here is a final practice for Chapter 4, looking at box and whisker plots, skewness, and kurtosis. So go ahead and pause the video, soak in these 4 box and whisker plots, and see if you can answer these 4 questions here. When you think you have all your answers, go ahead and unpause the video and see if you got them right. Alright, so let's take a look at our first question. True or false? The median for beta is less than the 75th percentile for alpha. Okay, so we have beta, and we see our median is right here for beta. So is this less than the 75th percentile for alpha? Well, where's our alpha? Here's alpha. Where's the 75th percentile? It's this line here, Q3. So is beta, the median for beta, less than the 75th percentile for alpha? Yes, this is true. Second question, which box plot demonstrates negative skewness? Negative skewness. So we see we have numbers here, but really we can look at the diamond relative to the median, and we see there's only one box plot where the median is to the right of the mean, and the mean is to the left of the median, indicating that the mean is being pulled to a smaller number, we see that delta demonstrates negative skewness. Let's take a look at question 3. True or false? The minimum for beta, that's right here, is equal to Q1 for gamma. Where is Q1 for gamma? It's the first line that makes up your box. So are they equal? Not quite. You see they're off just a little bit. So this is false. Last question. Which box plot demonstrates positive kurtosis? So when you think about positive kurtosis, is our distribution curve more narrow or wider? Like positive kurtosis. It's narrower, right? So the way you want to look at these box and whisker plots when you're thinking about skewness and really kurtosis is you're looking down on top of them. And the whiskers are essentially the ends of your distribution curve. And then everything else is in between. So we think about positive kurtosis, we're looking for something that is going to give us a narrow curve, which means that our box is going to be pretty narrow itself. So which of the 4 box plots has a narrow box? Alpha. So alpha demonstrates positive kurtosis. I'm going to ask you another question that isn't on here. Which box and whisker plot demonstrates negative kurtosis, or the most negative kurtosis? If negative kurtosis is looking at the widest, well, what are we going to be looking for? We want to look for the box plot that has the bigger box, the wider box, relative to the whiskers. So we see we have gamma. Gamma is going to be indicative of negative kurtosis. All right, so hopefully you got those right. If not, you got chapter 4 and homework 2 to help you and reinforce these concepts. All right, so let's summarize. Bar charts and pie charts are really used for nominal variables and grouped ordinal, interval, and ratio variables because essentially you're working with categories. However, histograms are used when you have ungrouped interval ratio variables, as well as line graphs because we can look at trends over time. So when we're creating groups from ungrouped interval ratio variables, there are rules that need to be followed in order to create those categories. We looked at how to create box and whisker plots and how they are useful to summarize central tendency, dispersion, as well as the shape of a distribution. And we did a practice with that just before this slide. But remember, we can only do box and whisker plots if we have numerical values, so ungrouped interval ratio variables and some grouped ordinal variables. Remember, if it makes sense and you can interpret a mean for a grouped ordinal variable, you can do the same thing essentially as ungrouped interval ratio variables. And looking at our properties of distribution, modality, skewness, and kurtosis.